positive Q cold. Okay, so let's move on. And so obviously this is a physical transformation. What happens when we do a chemical transformation? Okay, so here is the process known as calorimetry. So that's an experimental method that determines the heat released or absorbed during a chemical reaction. Okay, so here is a nice fancy high-tech calorimeter. I'm joking when I say that this is fancy and high-tech because it's just like 2 styrofoam cups. 2 to make it extra insulating. I'm going to show you what a real calorimeter looks like in a moment. Okay. But this is more or less what you would do in a Chem 109 lab situation. You'd have a couple styrofoam cups. Suppose we've got 25 milliliters of an HCl solution, 1 molar HCl, with a stir bar and a thermometer. And if we think about this, if let's say that this is now so this is going to be closed, because we can add mass to it, but it should be, excuse me. Let's just call it isolated. We know that we can take the lid off and add mass to it, but when that lid is on, we're going to say that it's isolated. And so if there is, let's think about this for a moment. If there's an exothermic reaction in an isolated system, it's going to cause the heat to rise, right? Because if there's this exothermic reaction going on, which, by the way, acid plus base is an exothermic reaction. So this wants to release heat, but because it's in this isolated container, it can't release heat. So what we do in calorimetry then is measure the change in temperature of this reaction. Also, if let's suppose we were doing an endothermic reaction in this calorimeter, we would see the temperature decrease. So that's how we know if something is exothermic or endothermic in a calorimeter. All right. So delta T will be positive for an exothermic reaction in a calorimeter, and delta T will be negative for an endothermic reaction in a calorimeter. So not only do we get that out of a calorimeter, that we can see that there is a temperature increase, and so that's evidenced by they're telling us the initial conditions with no acid was 25 mils of HCl at 18.5 degrees Celsius. And then the final condition was now 25 mils of HCl plus 25 mils of NaOH. And look, the temperature increased. So that tells us that it has to be exothermic. But not only that, but we can calculate the delta H of the reaction as well from this information. Okay, so how do we do that? So let's go for it. Okay, so here I've got more space